a number system with base 12 or base 60. You see, there are 60 minutes in the hour, and there are 60 seconds in a minute. So then the base number is larger, and as a result, as a benefit, the length of the strings of digits get shorter. So the question naturally arises, can we continue and increase the base number? And if we can, how far can we go in that direction to make the length of the strings of digits shorter? So the answer, I give you the short answer because, we can talk about this more, but I think the answer is surprising because a lot of people might just say that this is not going to work because you cannot have infinitely many digits. But the actual situation is that you can. And I wasn't the first one who introduced a number system which is using infinitely many digits. One of the great figures in 19th century mathematics, a German by the name George Cantor, invented a number system which is using infinitely many digits. But it remained a toy, basically. It did not become utilized in any significant way. However, don't forget that the binary number system was invented 300 years ago, and for most of that time, it was just a toy. It was remembered, and in schools they played with that toy and so on, but it was not really utilized until the computer age came around. So in the same way, I'm suggesting it to you that there is need for a new number system. But a number system which I invented, which I call Stepnumbers, and it's different from Cantor's, because it's far more economical with the use of digits. You have to remember that if you use infinitely many digits, you have a problem of remembering, So in other words, you do not want to use all these infinitely many digits all of a sudden. The human memory or even computer memory couldn't cope with that. So you have to economize, and you have to introduce these additional digits only when it's absolutely necessary. If you introduce them prematurely, then you are short-circuiting your memory units. So this is what I invented, is the step number system, which is doing just that. It uses infinitely many digits, but very, very economically. Now, you might have heard some talk about what they call quantum computers. Quantum as in the word quantum mechanics. And that's where the word is derived from, quantum mechanics. A quantum computer will be probably the next generation of computers, which is already, I think, in the drawing boards. It exists in blueprint form, not yet physically, but people are actually working on the idea, and the idea is this. The atom consists of a nucleus and a number of electrons orbiting the nucleus, just like the planets are orbiting the sun in a solar system. And there are lots of solar systems with a different number of planets. However, in the case of the atoms, there's a big difference, not just size, it's much smaller, but also the fact that these electrons, which are circling around the nucleus, are not free to take any orbit they want, because there are only certain orbits which they can occupy. So they can jump from one orbit to another, but these are discrete. They can't do this continuously. Now, you can imagine a planet circling around the sun, that over time it gets closer and closer to the sun because it's losing momentum, and we are talking about millions or hundreds of millions of years or light years or whatever. But the point is that this getting closer to the sun is a continuous thing, and such a thing cannot happen within the atom. We know that. Quantum mechanics does teach that, and experiments and so on justify this. What they can do is they can jump from one orbit to the next, and these are prescribed orbits, discrete orbits, and as they do, they lose or gain energy. So now take this atom, this model of the atom, according to quantum mechanics, and you can code the digits into these electrons circling about the nucleus by changing the orbits. Okay, so in other words, the coding of these step numbers, and there are infinitely many step numbers which are possible. Okay, you are not using all of them at the same time, but you do not limit them. So if you get to very large numbers and you run out of possibilities, then you have to get the next larger step digit. But this is possible because in the computer and in the computer memory unit, etc., you store the information supplied by the digits in the form of changing the electron orbit for individual electrons. Now, you see, I'm not an expert, so I stop here with the explanation of the mechanism, but the idea, I think, should be clear that whereas in the case of the binary system, all you need is a magnetic strip or tape or disk which can distinguish between the north and the south pole as far as magnetic polarity is concerned. In the same way, in a step number system, it will have to have something where you can register your infinitely many digits, and that can be done through this idea of using the quantum computer. So here is a problem. The hardware is already under development for a new generation of computers which will have a much, much bigger possibility to store information. The memory unit will be far more powerful than anything we have seen so far, you see. But the mathematics is not there because the binary system has its limits. So whereas most people today would say, well, that's final. The computer age is here, and even in the next generation of computers, the binary number system will be the language. That's the language of computers, and nobody can change that. Now, I am saying that this is not true. because there is a